systems and the various operations we are performing on the signals, especially the digital signals. So let us look into some of the concepts on this one. And the textbook referred for the digital signal processing is the DSP by Principles Algorithms and Applications by Prokis and Demonolokis. And some of the references books are this one. So before going to the actual DSP subject, let us look into some of the basic concepts. So let us see what is DSP. So as the name indicates, digital signal processing, the first concept is signal. So signal is nothing but, so already we are know signal is nothing but any physical quantity that conveys certain information based on the nature of physical phenomenon. For example, if I am talking the voice, so in this voice, there is some information is there. So that is the thing that we are going to convey the information on that physical phenomena. For example, if I'm giving the lecture on the DSP, so I'm conveying the information on the DSP. So that is called as a signal. It is going to convey the function of some data on the whatever the physical quantity we are going to take. So usually the signal, if it is a function of the single variable, we are going to call it as a one-dimensional signal. For example, with respect to the time t, if I'm talking at the beginning, it was the time was 0 second. As the time varies, the signal amplitude is also keeps on varies here. So that is, it's a function of the single variable, which is called as a time t. We are going to call it as a one-dimensional signal. We are going to call. Suppose if it is a function of the two variable, that is, for example, in case of the image, so it is a function of two variables, that is x and y axis. We are going to call it as a two-dimensional signal. We are going to call. So that is the examples of the number of dimensionality of the signal. And for the examples, we can consider the speech signal is one of the example where we are going to convey the information on what we are talking. So that is the example here. And we know in the digital signal processing, there are another two terms there, which is called as a signal processing. So signal processing is the thing, but we are going to perform the various operation on the signals we are going to perform. For example, the analysis of the signal we are going to perform, and also we are going to interpret the signal. Suppose if the noise is present in that one, that noise we are going to remove it. And if you're going to manipulate the signal, for example, if my voice is low, I want to amplify the voice. So that one you're going to call it as a manipulation of the signal, like you are performing the amplification of the signal you're going to perform. And this one can be performed for different types of things. For example, for the speech signal, we can perform. For the images, we can perform. Some of the images will be having the less quality will be there. So those images we can enhance the images here, and various things we can do it here. So that is the thing, but the signal processing. So it is called as the performing the various operation on the signal. We are going to call it as a signal processing. We are going to call. So usually the types of signal processing operation involves the two different types are there. One is called the analog signal processing. Other one is called as a digital signal processing. So analog signal processing is the thing, but for example, this analog signal processing we are going to do by using the analog circuit elements such as the circuit like resistors, capacitors, and amplifiers. Analog amplifiers you are going to use. So where we are going to take the physical, the signal will be taken, and by using the resistors and capacitor, we can remove the noise present in one that is called as a low pass filter, and we can amplify the signal by using means of using the op amp. So that is called as the analog signal processing operations you are going to call. So here in the case of the analog signal processing, so we are not going to consider the involvement of the digital computer. We are not going to consider. So only we are going to consider in case of the analog circuit elements will be considered, and we are going to perform the operation on that one. So, but the drawback of the analog signal processing is that, so here the lot of noise will be added in case of the analog signal processing operation because of the usage of the components such as the resistors, capacitor, and many more analog components. The noise will be added to the signal here. So that's a drawback of this analog signal processing operation. And also in case of the analog signal processing, so usually the whatever the output you're going, suppose if you're going to repeat the experiment for the number of times, so here the variation of getting the output will keeps on varies here because of the variation fluctuations in the analog components, because of the temperature or variation in the atmospheric condition. The other type of signal processing operation, which is called as the digital signal processing. So usually, as the name indicates, digital signal processing, we are going to consider the digital signal we are going to consider. So for that one, you are going to perform the operation on the signals you are going to perform here. So usually, in case of the analog, the signal will be the continuous in nature will be there. For case of the digital signal processing, the signal will be the discrete in nature will be there. So it is also called as the discrete time signal processing you're going to call. So here in case of the digital signal processing, we are going to perform the operations on the signal by either by using the digital computers we are going to use, or by making use of the digital process we are going to perform the operation. So that's why it is called as a signal processing and the analog and the digital signal processing. So here in case of the digital signal processing, the advantages are much more. Why? Because the clarity of the operations, whatever you are going to perform, the signal clarity will be very good. excellent clarity will be there. And also we can store that one by using the digital storage elements. So that's the advantage of the digital signal processing. And also the repeatability in case of the digital signal processing will be much accuracy will be there, because since you are going to write the program, we are going to use the DSP process to perform the operations, it is going to give the same result it is going to give even if you are going to run the program many more times. Okay, so that's the advantage of the digital signal processing. And let us see what is the kinds of the signal here. So here the digital signal is the thing, but so usually the signal which are practically existing is analog in nature. For example, whatever the voice I am talking, this is the analog in nature. So this signal we are going to convert into the digital by means of using the analog to digital converter. We are going to call it as a ADC. We are going to call this analog to digital converter. So in this case, ADC, there are three different basic operations we are going to perform. One is called as a sampling. The next step is called as a quantization we are going to call, and the last step we are going to call it as a encoding we are going to call. So here the input will be the analog signal, the output you are going to get the digital signal. The digital signal is the thing, but some data will be there in terms of the zeros and ones will be there. So actually the sampling in the ADC is going to convert an analog continuous time signal into the discrete continuous time signal you are going to obtain here. So discrete time signal in terms of the time, we are going to get the discrete samples you are going to get. So those samples will be given to the quantizer. The function of the quantizer is it is going to approximate the sample value to the set of nearest predefined levels. For example, so in case of the after sampling the continuous time signal, it is having the continuous range of amplitudes will be there. So in order to overcome that one, in those continuous range of amplitudes will be converted into a discrete range of amplitudes by using the quantizer, which is having the set of predefined levels will be there. So these predefined levels where the sample value will be approximated to the nearest predefined levels, so that we can able to obtain the set of predefined sampled values you're going to get, that is called as a quantization. So once we perform the quantization, the next step is called encoding here. So assume that we are going to use the 8 level of quantizers we are going to use here. So in order to represent the 8 level of quantizer, we require the binary data in terms of 3 bits are required here. For example, 2 to the power of n is the thing, but that is equal to the number of quantization levels. If n is equal to 3, so 2 to the power of 3 will be equal to 8, so that we can use the we can encode the each sample value by using the 3-bit binary data. For example, the first step will be encoded with 000, the next step will be 001, like that we can use. So we are going to get the digital data by using the analog to digital converter. Next, we are going to use a digital signal processor, which is going to perform the operation on the signals here. For example, it may be the filtering operation, it may be removal of the noise, it may be the modulation, it may be the demodulation, and many more things. Like if you want to remove some of the noise present in that one, we can do those are nothing but the signal processing operations. Then finally, at the destination end, we have the digital to analog converter, which is going to convert the digital signal back to the analog signal. Why? Because the digital signal is not audible, or it is not possible to hear by the human ears here. So then this signal will be going to the audio amplifier, and it will be finally it will be given to the respective at the receiver end, it will be given here. So these are the set of operations involved in the digital signal processing, where the analog signal will be converted into digital, perform the operation, digital will be converted to analog, and finally given to the respective user. Okay, so these are the operations. And some signal processing operation involves like removal of the distortion present in that one and variation, whatever these things will be, we are going to remove that one. And so this is the operations involved at the receiver end. So where we are going to use at the transmitter end, we are going to use a microphone, and it is consists of the amplifier. It is going to convert an analog signal into a digital one. Then we are going to give into the digital signal processor. It may be usually a computer. Then digital to analog converter we are going to use, and finally given to the speaker. So these are the operations involved if you are going to consider any system. For example, it may be our mobile phone itself. We can use this one in order to perform the operations. Okay. Now let us look into some of the concepts of the basic concepts of the signals and systems. So already we have seen the definition of the signal, anything which carries the information which is called as a signal here. So as I told the example, the signals may consist of classified into the different types. So one is the first type is the thing, but the continuous time signal. So the continuous time signal is the thing, but it is defined for the all the time interval t. If it is defined, we are going to call it as a continuous time signal. You are going to call. So usually the continuous time signal is varying continuously with respect to the time. The example is speech signal, or if you are going to record the noise, if you are going to record, that is continuous in nature. Okay. The other version of the signal, which is called as a discrete time signal, where it consists of the discrete time of samples. So it is represented usually in terms of the x of n, where n represents the number of samples if for example n is equal to 0, 1, 2, 3, so that indicates the sample number, and it is defined from minus infinity to the plus infinity. And the notation used for representing the discrete time signal is nothing but x of n is the notation we are going to use. For representation of the continuous time signal, we are going to use x of t. So similarly, the second kind of classification is nothing but the even signal. So even signal is nothing but it is a signal, or it is if it is symmetric about the origin, we are going to call it as a even signal. Or if it is going to satisfy the condition x of minus n is equal to x of n, we are going to call that as a even signal we are going to call. And other kind of signal is called as a odd signal. If it is going to be anti-symmetric about the origin, we are going to call it as a odd signal. Or else if it satisfies the condition x of minus n is equal to minus x of n, it is called as a odd signal. And the second kind of signal is nothing but periodic and non-periodic signals. So periodic signals are nothing but if it is going to repeat after the certain fundamental period, we are going to call it as a periodic signal. And if it is not going to repeat, we are going to call it as a non-periodic signals we are going to call. And another kind of the classification is there, which is called as the energy and power signals. So the energy of the signal is nothing but, so there's a formula we are going to use for calculating the energy of the discrete time signal. So if the energy is finite quantity, we are going to call that as a energy signal. Suppose if the energy is infinite quantity, then we are going to find the power of the signal we are going to find out. So that is called as this is the power formula. So if the power is finite, we are going to call it as a power signal we are going to call. So there is a case is that a signal either may be energy signal or maybe power signal, but it cannot be a both energy and power signal. So usually all the non-periodic signals will be assumed to be the energy signals, and all the periodic signals are assumed to be the power signals we are going to call. So usually in the digital signal processing, we are going to consider the discrete time signals you are going to consider, and especially the periodic and non-periodic signals are there. Both the things you are going to consider. So it is a discrete time signal processing, and we are going to consider the discrete time periodic and non-periodic signals, and we are going to perform the various operations we are going to perform. So it may be the finding the Fourier transform of the signals, and finding the from of the verification of the sum of the properties, and some filtering applications we are going to see. Basics. Let us move on to the sum of the transforms, which is called as a discrete Fourier